Hello everyone, welcome back to my YouTube channel. Myself Grishma, I am pursuing my BE in Sri Venkateshwara College of Engineering. Today's course title Operating System, course code BCS 303, topic Deadlock Concept. Contents that we are going to learn in this PPT are Introduction to Deadlocks, Resource Allocation Graphs, Deadlock Prevention, Methods for Handling Deadlock, Deadlock Avoidance, Deadlock Detection, Recovery from Deadlock. Deadlocks. In a multi-programming environment, several processes may compete for finite number of resources. A process requests resources, and if the resources are not available at that time, the process enters a waiting state. Sometimes a waiting process is never again able to change state because the resource it has requested are held by other waiting process. The situation is called deadlock. System model. Every process needs a resource to perform its task. Every process will do the following resource: request the resource, use the resource, release the resource. Deadlock. Deadlock. A set of process P1, P2 and Pn are in a deadlock state if and only if every process in the state is waiting for a resource that is held by another process in the set. Waiting versus deadlock. Deadlock, indefinite waiting, necessary condition. A deadlock situation can arise if the following four conditions hold simultaneous in a system. Mutual exclusion. At least one resource must be held in non-shareable mode, that is, only one process at a time can use the resource. If another process requests that resource, the requesting process must be delayed until the resource has been released. Deadlock. Hold and wait. A process must be holding at least one resource and waiting to acquire additional resources that are currently being held by other process. No preemption. A resource cannot be permitted, that is, a resource can be released only voluntarily by the process holding it after that process has completed its task. Circular wait. A set of process P0, P1, P2 and Pn waiting must exist such that P0 is waiting for a resource that is held by P1, Pn is waiting for the resource that is held by P2, Pn minus 1 is waiting for the resource held by Pn is waiting for a resource held by P0. Deadlock. There are two types of resources: physical resources, that is memory, CPU, printer; logical resources, files, semaphores. There can be multiple instances of each resource type: 4 printers, 3 scanners. Resource can be classified into two types: shareable resource. Reading a file, n process can read the file at time. Non-shareable resource. Writing a file, only one process is allowed at a time. When process requests a resource, the following two possibilities may happen. If resource is free, resource will be allocated to the requested process. If resource is busy, process will wait until resource will be free. Resource allocation graph. The resource allocation graph RAG is directed graph that can be used to describe the deadlock situation. RAG consists of set of vertices and set of edges. V is divided into two types of nodes: P, P1, P2, Pn, that is set consisting of all active process in the system. R equals R1, R2 and Rn, that is set consisting of all resource types in the system. E is divided into two types of edge: requesting edge, a directed edge. Rj is called request edge. The resource allocation graph shown in figure depicts the following situation. Deadlock prevention. Deadlock prevention can be eliminated by preventing at least one of four required conditions: mutual exclusion, hold and wait, no permission, circular wait. Mutual exclusion. This condition must hold for non-shareable resource. For example, a printer can be simultaneously shared by several processes. On the other hand, shared resources do not lead to deadlock. For example, simultaneous access can be granted for read-only file. A process never waits for accessing a shareable resource. Deadlock prevention, hold and wait. To prevent this condition, the process must be prevented from holding one or more resource while simultaneously waiting for one or more other resource. Two possible solutions to this problem. For example, consider a process that copies the data from a tape drive to the disk, sorts the file, and then prints the result to a printer. Methods for handling deadlock. The following are the three ways for handling deadlock. First one, ensure the system will never enter into deadlock state by deadlock prevention and deadlock avoidance. Second one, allows the system to enter into deadlock state, detect it and recovery from it by deadlock detection, that is an algorithm that examines the state of the system to determine whether a deadlock has occurred. Recovery from deadlock, an algorithm to recovery from the deadlock. Third one is ignore the program altogether and pretend that deadlocks never occur in the system. In this case, the undetected deadlock will result in deterioration of the system's performance. Deadlock avoidance. The general idea behind deadlock avoidance is to avoid deadlocks from ever happening. Deadlock avoidance algorithm requires more information about each process. With the knowledge of the complete sequence of requests and releases for each process, the system can decide for each request whether or not a process should wait in order to avoid possible future deadlock. Each request requires in making the decision based on the resource currently available, the resource currently allocated to each process, and the future requests and releases of each process. Deadlock avoidance. Safe state. A state is safe if the system can allocate all resources requested by all processes without entering a deadlock state. A state is safe if there exists a safe sequence of process P0, P1, P2 and Pn such that the request of each process Pi can be satisfied by the currently available resource. If a safe sequence does not exist, then the system is in unsafe state, which may lead to deadlock. All safe states are deadlock free, but not all unsafe state leads to deadlocks as shown in figure. Deadlock avoidance safe state. To illustrate, we can consider a system with 12 magnetic tape drives and 3 processes P0, P1 and P3. Table below shows maximum resource needed, currently allocation and how much they need to complete the work. Process P0, P1, P2, maximum need 10, 4, 9, current allocation 5, 2, 2, need 5, 2, 7. Thus, there are 3 free tape drives. At time t0, the system is in safe state. The sequence P1, P0, P2 satisfy the safety condition. And this is the deadlock avoidance for a deadlock avoidance, and the second one picture is an unsafe state. Deadlock detection. Deadlock detection. If a system does not employ either deadlock prevention or deadlock avoidance algorithm, then a deadlock may occur. In this environment, the system must provide an algorithm to examine the system state to determine whether deadlock has occurred, an algorithm to recover from deadlock. Single instance of each resource type. If all the resources have only single instance, then deadlock detection algorithm can be defined using a wait for graph, that is WAG is a variation of the resource allocation graph. The wait for graph is applicable only to a resource type with single instance. The wait for graph can be obtained from a resource allocation graph by removing the resource nodes, collapsing the appropriate edges. Deadlock detection. An edge from Pi to Pj implies that process Pi is waiting for a process Pj to release a resource that Pi needs. An edge Pi to Pj exists if and only if the corresponding graph contains two edges, Pi to Pq and Pq to Pj. For example, consider resource allocation graph shown in figure A and its corresponding wait for graph is shown in figure B. Recovery from deadlock. When a detection algorithm determines that the deadlock exists, several alternatives are available. One possibility is to inform the operator that a deadlock has occurred and to let the operator deal with deadlock manually. Another possibility is to let the system recover from deadlock automatically. There are two options for breaking a deadlock. One is simple to abort one or more process to break the circular wait. The other is to permit some resource from one or more of deadlocked process. Thank you for watching my video. Please do like, share and subscribe.